Hello, my name is David Kowalski. I'm an account manager with Qnect. Today we're going to be covering how to use analytics for better job performance. Today our agenda is going to be who we are, what we do, demo of the software, and then we're going to have a question and answer session. So who we are at Qnect. Qnect was founded in 2014 by Jeff Sharp, Henry Lederman, and Jeff Hauster. Qnect is headquartered in Hadley, Massachusetts. The Qnect team has over 80 years of experience in the steel industry. So what Qnect does is we're able to integrate connection engineering modeling back into a Tekla 3D model with the following benefits. Our first benefit is analytics, early data analysis for smarter decision making. Two, we're able to create buffer time to prevent schedule drift. And three, we're able to maximize the number of beams that go into one station fabrication. And last, we reduce the time to fabricate and erect through our optimization tools. Today we will focus on analytics. So without any further ado, Henry Lederman.
Thank you, David, and welcome everyone. I'm very happy to be here with you today. Today we're going to discuss analytics. Qnect is proud to offer important and significant early data and computational analysis support, resulting in better decision making for your job and company success. What makes this possible is the fact that Qnect is extraordinarily fast and gives you a ton of data, but with the time to think about it and to make good decisions. Let's just go over some of the ways we do this and what we provide. First, we'll actually run the building 9 different times, trying different joint configurations, single angle, double angle, shear plates, 3/4 inch bolts up to 1.1 inch. We'll analyze the data for the lowest cost joint configuration within the resources that you say are available and within the requirements that you have. You'll see the data. We'll offer our thoughts and analysis. We'll review the members that are coped that need to be reinforced by providing you a report that shows you the capacity of the beam prior to reinforcing, that allows you to talk to the engineer to either reduce the loads or upsize the beam. You'll have the ability to review specific output data for every joint and for the joints globally, plate thicknesses, bolt size, single pass weld, etc. We'll define any conditions for elimination of copes. For example, if your shop are coping manually, this is very expensive, and we could look at ways to eliminate copes. And certainly from an analytics standpoint, to identify the number of cases that are possible for conversion. And we can identify and will identify beams with 2-station fabrication to and maximize the conversion to 1-station fabrication. So there's a lot here. And again, it's going to happen in the estimating stage or production. Let me sort of start at the end just to bring you visually right into what analytics could entail, and it's more than what you're about to see. So this is one specific joint that we're looking at on a job that is still in the estimating bidding stage. This first picture here represents the design requirements. The beam is filled up, 3/4 inch bolts, and the connection requirement is 66 kips. But as you can see here, the capacity is 159. So it's extraordinarily high in terms of what is needed. Sometimes you can bring this kind of reduction as a VE credit to the bidding process. But we can see we need 18 bolts. The engineer wants 2-angle conditions. Once we remove this fill the beam up criteria, we now see that we can reduce the bolts 50%. We still have extraordinary amount of capacity of 90 kips, still 3/4 inch bolts and 2 angles. So huge improvement. But then we can look and see, all right, well, can we use a single angle? This would be a case where your shop would like to see bolting more than welding. And sure enough, our capacity is a little bit more than the reaction, just almost the same. And we do have one more bolt in this condition, 8 bolts less than the first condition, but now we have 1 angle instead of 2, and an easier to erect. But then we can go one step further during the analytic process and say, all right, what happens when we use 1-inch bolts? And as you can see, a dramatic drop in bolts from the original 18, only a third, so we've dropped about 2/3. We do need a 1/2 inch angle, and the capacity is certainly well within what we need. And now we have data, interesting data, that allows us to say, okay, what can we do here? What is the best for us, or you, the fabricator? So I want to kind of paint this picture on a joint, but really what we're doing in this analytics stage is running the whole building with these multiple, in fact, 9 different options. So let me now continue and go to the beginning and show you how this all works. So I'll start with a quick refresher. And as you can see here, we're now on the Qnect website. We're doing this job, demo building, and we've set up all the preferences that would determine the design requirement. Preference optimization and bolt optimization will be part of the analytics data that we will have to make these decisions. Just as another example of one of the preferences, you can see here is where we set up the conditions, double angle, welded voltage, extended shear plate, etc., etc. And so we're setting it up for the fabricator and their needs, and then we're going to run accordingly. Let's now go into so again, once this is all set up, it takes about 40 minutes, and this information can be copied for the next job. Now we're ready because every connection will be done that way. All right, so we're now in the Tekla model. As you can see, it's a stick model. There's nothing here. And when we go to Qnect, you'll see our Qnect tabs. And we select from the lower right, upper left. We hit button 1. And I'm just going to show you how this works. We're typing any session name, and we would typically submit. We're not going to do that today. It'll pull the data up to the website, organize it, engineer it, and then when it's ready, we'll send you an email, and we're going to pull it back down from the web. Each joint has a custom design, both custom design and custom component. So it's extraordinarily efficient and fast. We do this whole joint and whole building in 1 minute and 20 seconds. We'll do any building, no matter what size. We're able to run the whole analytics within 24 hours. But as you can see, all the connections have been returned, at least about 60 to 80%. We have moment connections. We have top and bottom moment plates with shims and deck support. And so this is the typical process. Button 1, button 2. Now, to continue the analytics story, I want to just show you one of the ways we optimize, and that becomes part of the 9 runs we do. In addition to the 9 runs, we're simultaneously optimizing each joint. So here we have a joint, it's 6 bolts. We're going to optimize that. So we'll delete, we'll select 1, we'll select button 2, we'll hit button 1. Again, we won't do the process because I've already done it. We'll look for the return joint. It was analytics 2 that I did, and we submit. And as you can see with optimization, in this case, it's a substantial reduction, very much like the case we saw also on the beginning of this webinar. But with optimization, we often typically see 1 to 1.5 bolts per ton in savings. In this particular case, we have 1, 2, 3, 4 fewer bolts, 6 fewer bolts to purchase. We have 2 fewer bolts in the shop to install, 4 fewer bolts in the field, and 12 fewer holes to drill, cut, or punch. So that's sort of how the data collection happens. We're selecting the whole building. We're running it 9 times, and we're checking different configuration, and we're optimizing at the same time. So let me show you how that data might look. Here is a report of a job that has 1, 2, 3, excuse me, 4, 5, 6, 7, 8, 9 jobs. We have the baseline, which is what the client says they would like to use, and we have all kinds of different configurations. Now, we don't have to stop here. These are default settings we've come up with, but we could try other things. In the group from here to here is the standard connection, which is 3-inch vertical spacing, and it gives you the shop erection and total cost. As you can see, if you just wanted to compare blindly, meaning without restraint of resources, we can see that we have 7,000 bolts. We can get down to 5,000, or 259,000. We can get down to 230. So again, a lot of data. We can then look at the optimized joint, similar to the sketch, the joint I just showed you, and we could see if we stayed with the baseline, 5,000 bolts versus 7,000, and a savings of 42,000. But if we just went to the lowest cost, which looks like 177 in the total cost, we would compare that to 259, substantial savings. Similarly, 5,600 bolts versus 7,000. Again, good data to understand what's going on. But let's dig a little bit deeper, and we'll look at the one of the output, data output, number of plates. You'll see here we have doubler plates where the beams are coped and reinforced. And to understand that, we will go to the doubler report, again, analytics during estimating or production. And we could see, for example, small beam to a very large beam, reactions 30, and this connection is only good for 25. Not a very heavy lift to imagine the EOR will be able to reduce the load, but in other cases, maybe he upsizes the beam. 1626, 40 kips to 33, etc. So that's another part of analytics. And we continue down, we will see all of the welds that are currently in the job, exact fillet weld, CJP, PJP, and exactly all the bolts. All of this information can be provided through a KISS file or an Excel export, and we've exported one of the jobs. We'll show you what else we can do with that information. So let's take a look at an exported file. And here you can start by, just understanding the nature of the connection. Are they always 3/4 inch bolts? No, we have some 1-inch bolts. What is the thickness of the, in this case, angle material? I see we have 3/8, and we could sort this Excel file to see, are we getting angles, sizes that we want to work with? Because you can limit the sizes on the Qnect website for exact sizes that you want. But we are getting a window into the future of this job running through the shop. And we're able to determine, to observe, and to correct where we want to, angle sizes, plate thicknesses that we want to make sure make sense for us and that works for us. We'll also see vertical spacings that we're using, 3.5, 4, 5. We can limit the vertical spacing as well. We don't have to go 3, 3.5, 4, 4.5, 5. We can go 3, 4, 5, but we can see the kind of quantities that are being produced. All right, so this is, again, all part of analytics. And the last piece I want to just quickly show you, is that we will color code the entire building once it's connected for the beams that are two-station fabrication. As you can see in this case, there are quite a few in this building. And through an iterative process, because we don't know for sure if the connection will be able to be changed so that it is one station, but we certainly could work to create that. And then we would come into the model and look for, take the beam, and let's say we would change the end connection to a welded or bolted condition by simply correcting the end condition locally. So in this place here, we'll try different iterations. So let's just come back to the overview of the analytics. And again, there's a lot to show. I've shown you a lot. Early data is everything, because you can then make the right decisions for your job, each job being different, for your resources, even mixing up welding versus bolting depending on the backlogs you see. And all of this will happen even during estimating, but most important, when you have some time to think. As you know, jobs pull you very quickly, and the pressure is intense, and there's no time to review. So again, 9-joint configuration, lowest cost, review beams that need reinforcing, review all the output data, specifically as you saw in the Excel spreadsheet, potentially eliminate copes, and identify two-station fabrication. With that, let me turn it over to David to see what questions you folks may have. So thank you very much.
So now I'd like to move on to the question and answer segment. We have a couple of questions here that I'd like to go over. The first one for you, Henry, would be, do your clients currently use analytics in estimating?
Thank you, David. And again, thank you everyone for being here. Yes, they absolutely do. In fact, we have several clients that we've integrated fully with their estimating process, where we've done some custom programming to integrate fully. And we go through the analytics, much of which you saw today, to support their winning of a bid. Thank you.
Thank you, Henry. The second question now we have is, do EORs accept varying bolt spacing?
Okay, so I guess that question applies to the varying of the vertical bolt spacing. That is the basis of our reduction of time to fabricate and erect. Primarily, the vertical spacing is 3 inches on most conventional systems everywhere. And we vary that spacing from 3 to 6 inches in half-inch increments, selecting the vertical spacing with the fewest number of bolts. I believe that's what the questioner is asking. First, I'll say that for some clients, the iteration through those increments 100% is fine with them. For others, they like to use 3-inch, 4-inch, 5-inch, or 3, 4.5, and 6. So you have a lot of flexibility. EORs, through all of the projects we've done, have never complained about it. We provide complete and accurate limit state calculations that is completely pieced out by our connection engineer, a partner. And once they understand the integrity and the quality control, they actually are pretty happy to to do their approval process using the Qnect system. So we still, you might decide to ask for permission, but typically if the engineer says you're to design the joint, we proceed, move forward, and we don't have a problem with it.
Thank you, Henry. So the last question we have over here is, who manages one-station fabrication and how?
Okay, so the one-station fabrication is managed by Qnect. In our workflow, we will work with the detailer for the first several jobs to help the transition from the way they think about and process today to this change in methodology. So we'll take their model, either a live model while it's not in use by them or through model sharing, and we'll take our software, which will run through the building, color code the beams that are that have two-station fabrication, as you saw in the video. We also can color code other things, like all the beams that have no copes and just holes, in case they want to selectively fabricate a group of beams that becomes a backlog. So we'll take the model, we'll run it, we will identify the conditions, and then we will, through an iterative step, check the engineering to see if the change for the connection, that is a change within the parameters that the fabricator has set, will actually conform and result in a one-station fabrication. Once that's done, we'll identify that locally, and now the detailer can take it back either with the connections or run it later themselves.
All right, thank you very much. So I'd just like to thank everyone for attending this webinar today. And also, I wanted to let you know that I have our contact information here that you'll be able to find Christian Erickson's contact information as well as my own below. Feel free to reach out to us with any questions in regards to the webinar or any questions about Qnect. And once again, thank you all for attending.